Alright, so in this short video, we're discussing proving triangle similarity using the side-angle-side similarity theorem. These examples were pulled from a larger video, which covers all three of the theorems, side-angle-side, angle-angle, as well as side-side-side similarity. So if some of the example numbers are off, it is because I pulled these examples from my larger video. But this video only covers the side-angle-side similarity. So let's go ahead and get started. The side-angle-side similarity theorem states that if an angle of one triangle is congruent to an angle in the second triangle, and the sides that include the two angles are proportional, then the triangles are similar. So we're looking at these included angles here. So angle A and angle Q are included, they are congruent. The sides have to be proportional as well. So as an example, let's say this side was 4, AB, and this side was 10, and AC, let's say that was 6, and QS is 15. So AB over QR would be 4 over 10. That reduces to 2/5, right? And then AC over QS, that is 6 over 15. That also reduces to 2 over 5. And so those sides are proportional, and so we could say that these two triangles are similar using the side-angle-side similarity theorem. Let's take a look at these two examples here. So example 9, we could already see that these two angles are congruent, and we know that because they are vertical angles. So we already have an included angle there. All right. And so next, let's look at our sides here. So our shorter sides for each triangle are side 6, or has a length of 6 and 24. So that is FE and ER. So we can write that as a fraction, 6 over 24. And let's go ahead and reduce because we can, and that reduces to 1/4. Our larger sides are 12 and 48. 12 over 48 reduces to 1/4. All right. So the sides are proportional, and we have those included angles that are congruent. And so we could say that these two triangles are similar using the side-angle-side theorem of similarity. And let's go ahead and write a congruency statement. So FE, I could say that triangle FEG is similar to triangle RES. All right, and so we could see that those corresponding sides are actually in the same position. All right, so now let's look at the second one here. So we have a triangle within a triangle. So this side here would be 39, side GL. Side BL would be 7 plus 27. That's 34. So I'm just adding these two to get the size of that larger triangle. All right, we already have an included angle here. So those two angles are congruent because these two triangles share an angle, but let's see if the sides are proportional. So if we're looking at this side here, so our shorter triangle has a side length of 27, and that longer side, or that larger triangle, has a side length of 34. And then right here our other side, GL and XG, or GL and XL, I'm sorry. And so the length of that smaller triangle would be 30 over 39. We can't reduce them, all right? So we could see that these are not proportional, and so these triangles would not be similar. So although they have an included angle, they are not similar because the sides are not proportional. I have a problem here that I would like for you to try on your own, and it asks, are the triangles similar? If so, write a similarity statement for the triangles. So go ahead and pause the video and try this problem on your own. These triangles are, in fact, similar using the side-angle-side theorem. All their sides, or the two sides, are proportional. They reduce to 4/5. And the included angle right here, so we can see here and here, they are congruent because they share that angle. And so since the sides are proportional and the included angle is congruent, we can conclude that these two triangles are congruent. Hope you got the problem correct. Or these two triangles are similar, not congruent. So I hope you got the problem correct. All right, so we've reached the end of our short lesson here. I want to thank you for learning with me. Some related videos are similar polygons, side, and angle similarity, as well as the triangle proportionality theorem or the side splitter theorem. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.